Reshaping a matrix looks like it needs a straightforward approach, but there's a clever trick to simplify the process. The problem asks us to reshape a given matrix into a new matrix with a specified number of rows and columns. For example, if we have a 2x2 matrix with elements 1, 2, 3, and 4, and we want to reshape it into a 1x4 matrix, the resulting matrix should have the elements 1, 2, 3, and 4 in a row major order. The question is, how can we achieve this efficiently? One possible approach is to iterate through the original matrix and copy its elements into the new matrix. However, this brute force approach has a time complexity of O, M, N, and a space complexity of O, R, C, where M and N are the dimensions of the original matrix, and R and C are the dimensions of the new matrix. This approach works but is not particularly efficient. The key insight here is that we can use a single index to keep track of the current position in the new matrix. We start by checking if the total number of elements in the original matrix is equal to the total number of elements in the new matrix. If they are not equal, we return the original matrix as it cannot be reshaped. Then, we create a new matrix with the specified number of rows and columns. We iterate through the original matrix, and for each element, we calculate its corresponding position in the new matrix using the index and the number of columns in the new matrix. You'll recognize this pattern when you need to transform a matrix from one shape to another while preserving its elements. The time complexity of this optimized approach is O, M, N, where M and N are the dimensions of the original matrix. The space complexity is O, R, C, where R and C are the dimensions of the new matrix. Try the next problem on matrix manipulation. You'll find that this pattern of reshaping and transforming matrices is a common theme in many problems. Don't forget to subscribe and ask questions in the comments.